Hey guys, yes, as you can hear, my retro challenge entry is moving along. It's a Microtronic emulator based drum computer. So I've made some more changes to the opcodes. I'm able to, in real time now, play the drums using the keypad. Let's have a quick look at the program. As I explained in my previous videos, I have extended the opcodes in the Microtronic, which have a basically non-semantically meaningful semantics, so they are vacuous in a sense. Not really no ops, they do something, right? But it doesn't make sense what they are doing. And those opcodes I have extended to give them extra side effects, such as turning on the MIDI mode, so data is being sent to the X2 general MIDI module, or sending out MIDI data, right? And so here the first opcode enables the MIDI mode, and then I'm displaying one register starting from register 4, so register 4 is being displayed. Then I'm using the kin keyboard input command to input from the keypad into the register 4, and that is simply being output. And then there's a go to command, it goes in a loop, right? So you can tell that this is register 4, input is requested, this is why it is blinking now, and then of course the keyboard input command is a blocking command, so it waits for a sound, for a key press, and then the program continues. And of course that only works basically with 16 drums that way. There is no non-blocking input command, so if you wanted to have more drums or really use the 7-bit 2-digit MIDI drum numbers, then you cannot input them that way, right? But I think 16 drums are of course enough. So obviously you cannot play the drums if you have blocking keyboard input and are waiting for 2 digits from the display, right? That would be tedious or impossible to drum along. However, for a MIDI tracker, right, usually you have like a beat, and in real time you are playing basically the drums on the keypad. For that I would really need some non-blocking keyboard input, and I need to figure out how to extend the opcodes or the semantics, change the semantics of the kin command basically in order to use that opcode for non-blocking input. But I also have a little sequencer by now, so let me load that from EEPROM. That's not a sequencer, it's basically a drum computer tracker, right? And so that goes as follows. I input 8 drums now into 8 registers from 4 to 8, 4, 5, 6, and you see the first 4 here, and I can now play drums. To slow it down, and then the playback starts. And as I said, ideally I would now like to be able to change the pattern, right? And input or correct certain drums, play around and have an immediate idea of how the pattern sounds like, the drum loop, but I can't do this currently. So it is a 2-step process. First, I'm using non-blocking input to input the drums in a blocking way into 8 registers, and then they're being played back in a loop. And obviously, I mean, we could also have 16 or even 32 node drum patterns, because this is how many registers we have. yeah, how does that program look like? Again, we enable the MIDI output mode. Then we are displaying 4 registers, starting from register 4. So 4, 5, 6, 7 are displayed. I'm using keyboard input into register 4. And now 044, this is one of those vacuous opcodes again, extended with special semantics for MIDI, means copy or move register 4 onto itself. Of course, it doesn't do anything semantically meaningful. So it outputs basically the content of register 4 to MIDI, and it's a MIDI node on, and the content of the register 4, the 4-bit value, is being interpreted as a 4-bit drum number, right, from 0 to F. So 16 drums are predefined. Usually you need 3 bytes for a MIDI node on message, and that would of course use too many registers if you wanted to do it on that level. So there's a special MIDI drum node on message here that only requires a 4-bit value, right? And so in that way we can immediately get feedback. We hear what we just inputted. Then there's blocking input into register 5. I output this for confirmation also, so we can hear what we just pressed, and so on. I do this for all 4 registers from 4 to 7, and then I'm switching to the display from register to display register 8, 9AB, and I'm also inputting the remaining 4 counts to registers 8, 9, A and B. Same story. And then basically the drum loop starts, right, because we have specified all 8 beats and all 8 drums. And now I'm just in a loop outputting drum in register 4. This is a go subroutine at address 50, and I'm using this to slow it down, right? So at address 50 we can take a look. B50 is basically call subroutine at address 50. If you look at 50, you see the F01 is just a no-op operation, and then it has another no-op, so there are 2 no-ops, and then F07 is a return, right? So all it does is allows me to time basically the steps in between in between individual beats. So where were we? Here, right? So, and then I'm doing this for all the remaining registers 5, 6, 7, 8, 9, AB. I'm always calling B50 in between, and then when the loop is done after 0BB, I'm not calling B50, but I'm calling B60, and the difference is that after the last step there's a go to, right? So go to address 13, this is a loop, and that instruction is obviously 1 opcode more. So if we use the same delay for this step, you would hear it actually, that it is too slow. So I can demonstrate this. If I replace this with B50, then you will hear that the drum loop is not running at a constant speed. You hear that there's a slight lag after the 8th beat, right? Here. So this is why after the last beat I'm using 1 no opcode, basically less here. So this is B60 instead of B50. And then it runs smoother. Yeah, alright guys, so that was my retro challenge update number 3. Thanks for watching.